Chapter 6, Discrete Probability Distribution. Earlier we talked about types of variable, discrete and continuous numerical variable. Discrete, number from counting, and continuous, number from measurement using devices such as the thermometer, speedometer, ruler, and so on. Random variables, discrete and continuous. Numbers from counting, the number of students, counting, that is discrete. And continuous random variables, values from measurement such as weight, height, temperature, and so on. Practice problem number 4. Which of these variables are discrete and which are continuous random variables? Question A. The number of new accounts is established by a salesperson in a year. The number of, so discrete. The time between customer arrival to a bank ATM. Time, measurement, continuous. The number of customers in Big Nick's barber shop. Number of customers, counting, so discrete. The amount of fuel in your car's gas tank. Gauge, measurement, so continuous. The number of minorities on a jury. That is, number of counting, discrete. The outside temperature today, temperature, thermometer, measurement, so continuous. Probability distribution, a listing of all the outcomes of an experiment, tossing a coin, observing, and so on, and the probability associated with each outcome, the probability between 0 and 1, as you know, the outcomes are mutually exclusive. Each outcome mutually exclusive. The list is exhaustive. You know, probably something happened. Probability distribution for discrete random variables, so mutually exclusive listing of all possible numerical outcomes for that variable, such as their particular probability of occurrence is associated with each outcome. Something like this. If we toss a coin 3 times, then possible outcome head, 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 tail, head, tail, tail, head, tail, head, tail, head, head, tail, tail, head, tail, head, head, tail, 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 like this. Then the number of head, 3, 2, 1, 1, or 2, head, head, and then 2, head, head, 1 head, no head. So number of head, 0, tail, 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 only 1 time. Number of head, 1 time, 1, 2, 3. So there are 3 times of number of head, 1, and 2 head, 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 3 times, and then 3 times of head, 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 only 1 time. Then 0, 1, 1, 3, 2, 3, 3, 1. Something like probability distribution. That is probability distribution. There are three types of discrete random variable distribution. First one is binomial probability distribution. Like a bicycle, because there are two wheels, so we call that bicycle. Bi means two, so if there are only two possible outcomes, such as tossing a coin, head or tail, class, passing or not passing. If there are only two outcomes, passing or not passing, that case we should use binomial probability distribution. Combinations. Combination and permutation. You may have lock number set and then open and so on. The lock's name is combination lock, but in statistic concept, the name combination lock is wrong. Combination, if we have total number is n, among them pick some. It's like there are 10 possible numbers and then pick 3. That case, n is 10, x is 3. Combination x out of n equals n factorial. You know factorial. If 3 factorial, if it's 3 factorial, means 1 times 2 times 3. If it's 4 factorial, actually reverse, 4 times 3 times 2 times 1. That means from 1 times up to that number factorial. X factorial times n minus x factorial, that is combination. Permutation, r out of n factorial divided by n minus r factorial, this is permutation. Okay. If there are three numbers like 1 to 3, then 1, 2, 3, 3 numbers, then if we pick 2, then make something group. So we can pick 1 and 2, 1 and 3, 2 and 1, 2 and 3, 3 and 1, 3 and 2. All possible group. So 2 out of 3 possible outcome will be 1, 2, 3, 4, 5, 6. 6 possible outcomes. So using permutation, 3 factorial, 3, n and r, 3 factorial, 3 minus 2 factorial, that is 1 times 2 times 3 divided by 3 minus 1 is 1 factorial, that is 1, equals 6. So by permutation formula outcome is 6, different 6 outcomes like this. If this one and this one, 1 and 2, 2 and 1, member, only member, 1 and 2, 2 and 1. The order 1 and 2, 2 and 1, order doesn't matter, just a member, then 1 and 2, 2 and 1 is the same. Order doesn't matter, just a matter of member. Who are they, what are they? 1 and 2, this one and this one, 1 and 3, 3 and 1, order matter than different, but order doesn't matter, then 1 and 3 the same. 2 and 3, 3 and 2, order matter than different, but order doesn't matter, then 2 and 3 member the same. So order doesn't matter, that case only 3 possible outcomes. Combination 3 and 2, 3 factorial divided by 2 factorial times 3 minus 2 factorial, 1 times 2 times 3 divided by 1 times 2 times 1, that is 3. Only 3 possible outcomes. So combination log, if I said 1, 2, 3 or 3, 1, 2, members the same, but because order matter different, 1 to 3 and 3, 1, 2, 3, 2, 1. So if order matter, then permutation. Order doesn't matter, combination. The combination log, order matter. So we should call that log permutation log, not combination log. Why I show you combination and permutation is binomial distribution use this combination formula. So probability X is like 10 students here, and then what is probability of passing this class? Like probability of 3 students passing this class, 4 passing class out of 10, like that. X combination X out of n pi, that is given probability average passing this class is like 0.8. 80% of students pass this class. That case, pi, that is 0.8. 1 minus pi n minus x power, that is, this combination is this one times pi x and so on. Example, determining, this one is binomial. Probability x equals 3. 3 out of 4. 3 out of 4 will be this one. Probability is 3. 4 factorial divided by 3 factorial, 4 minus 3. Anyway, binomial distribution looks like this. Y longer tail, y skewed or positively skewed. Then n is 4, total possible one from 0, 1, 2, 3, 4. And then this one as individual probability. Using the formula, we can get this result. Factorial, 3 factorial, 4 minus 3 factorial equals 1 times 2 times 3 times 4, 1 times 2 times 3 factorial, times 4 minus 1 factorial. So, we can delete 1, 1, 2, 2, 3, 3. 1 factorial equals 1. So 4 divided 1 equals 4. So 4, this is 4 times 0.1, 0.1, third power, times 0.9, 4 minus 3, 1 power is just 0.9, so result is 0.0036, 0.36%. Probability 3 or more, that is like this. If n is 4, possible probability is 0, 1, 2, 3, 4 from 0. X greater than or equal to 3 equals 3 and 4. Probability x greater than or equal to 3 is 3 plus 4. We have probably 3 already. We need probably 4. 4 factorial or 4 factorial times 4 minus 4 factorial, 0.1 fourth power 1 minus 0.1, 4 minus 4. Four minus 4 is 0. 0 factorial equals 1. 1 minus 0.1, 0.9, 4 minus 4, power 0.9, 0 power, 4 minus 4 is 0, that it will be 1. So 0.1, 0.1, 0.1, 0.1, this is 0.1, this one is 1, because this is 1, 4 factorial, delete. 0.9, 0 factorial is 1, so 1 and 1, 0.1 times 0.1 times 0.1. First power, that is 0.0001, 0.01%. So, probability x greater than or equal to equals 0.003 probability of 6, x equals 3, and probability x equals 4. This one equals 0.0037. we can use formula to find the answer like this, or we can use chart like this. This one from our textbook, and the chart is, if you don't have a textbook, find binomial probability distribution table on Blackboard under document, course material. Something like this. But condition n equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Our textbook provide up to n equals 15, and also probability of pi 0.05, 0.1, 0.2, 0.3, and so on. If a question gives you a pi, the probability, average probability, like a 0.16, then you can use this table. But when you take midterm, I will give you probability based on this table. Let's use making this charts. So if probability is less than 3, x equals less than 3, that is probability 0 plus probability x, 1, probability 2. When pi is 0.1, n is 4, then using this chart, n is 4 and then pi is 0.1, then this is probably 0, 1, 2, 3, 4. Probably 0 is 0.656 plus 0.292, 0.049 from the chart. Here, when n is 4, pi is 0.1, p probably 0, 1, 2, 3, so probably 1.656, probably 1.292, probably 2.049. So we can find individual probability from the chart, binomial distribution chart. Mean and variance of binomial distribution using formula like this, then you can find. But I will not ask this mean and variance, not in test. Practice problem number 18. It is reported that 16% of American households use a cell phone exclusively for their telephone service. In a sample of 8 households, question, 16% American households use a cell phone. Okay, use cell phone or not. Only 2 outcomes. So this problem is binomial distribution problem. And find probably that no household use a cell phone as their exclusive telephone service. when you solve binomial distribution table problem, binomial distribution problem, then you need n here eight household, and you need pi average probability 16%, 0.16. Like I said earlier, if you have probability pi, one of them 0.05, 0.1, 0.2 like this, then you can use table, but not in the table, then something like this 0.16, then we should use formula. When is n equals 8, pi equals 0.16, we cannot use table, then we use formula like this. 8 factorial divided by 0 factorial, 8 factorial times 0.16, 0 power, and so on. X equals 0, then is 0.2479. Just to show you, and question B, find the probability that one or more looks like this: 0, 1, 2, 3, up to 8. Question A, probability x equals 0, that is only this 0 individual, this one. But this question, find the probability that one or more probability x greater than or equal to 1. That is, including 1, 2, 3, 4, 5 up to 8, this area, P1 plus P2 plus up to P8. That case, just find the 1, 2, 3, 4, and 8 add, or the concept total probability is 1. So P x greater than or equal to 1 equals 1 minus total minus this much, that is right side. So P 0. So we already have P0, probability of x equals 0 already. Probability of x equals 0 equals 0.2479. So 1 minus total minus this much, 0.2479 equals 0.7521. So 75.21%. Next question. Find the probability that more than 3 households use a cell phone exclusively for telephone service if 20% of American households use a cell phone. 20%. Pi equals 20.2. And still 8, and pi equals 0.2. We may use binomial distribution table. Anyway, 8, 0, 1, 2, 3, 4, and so on. Find probability that more than 3, p, x more than 3, that will be, 3 is not included because there is no equal sign. So probably x equals 4 plus probably 5 and so on up to 8. This area equals, from the table, this one, let's make bigger. From the table, find n equals 8 here, n equals 8, then probability 0.2 pi, 0.2 here, then find P4, P5, P4, 0.046, 0.05, 0.009, probably 6, 0.001, and so on. Find individual probability and add them. Probability x equals 4 is 0.046, probably x equals 5 is 0.009, probably x equals 6 is 0.001, and so on. So probability more than 5 equals 0.0056, 0.56%, 0.56%. That's binomial distribution, And next one, Poisson distribution, discrete probability distribution, and Poisson distribution. Binomial, if outcome is only two possible outcome, then binomial distribution. If something number, counting number, the number times a particular event occurs in a given opportunity, something time, length, surface, area, and so forth. In this classroom, how many students in this classroom? counting 10 students here, 10 students here, and in 10 minutes, first 10 minutes, how many students come in this class? Time, in certain time period, area, surface, then how many? Another example, how many table here? Count numbers, so discrete, and in certain area or surface, number counting. That is Poisson distribution. Poisson distribution is, we call this something. The probability approaches 0, but never touch, something like this. Binomial distribution, there is maximum number, n equals 8, n equals 10, something like this. But Poisson distribution, there is no maximum number, infinite. So it goes approach to 0, but never touch. Poisson distribution using this formula, mu is average mean, and then x power probability of x. E, we call this natural number, mathematical constant number, always 2.71828, minus mu, average power, divided by x factorial. The mean number of customers who arrive per minute, certain time, how many? So this is Poisson distribution. At the bank, during the noon to 1 p.m. hour is equal to 3, that is mu. What is the probability that in a given minutes? For this Poisson distribution, when you solve binomial problem, then you need n and pi. But for Poisson distribution problem, you need mu. Mu is 3, given average is 3. Then probability x equals 2, exactly 2, something like this. If we use formula, this one equals 3 square, E is 2.71828, and then minus 3 power divided by 2 factorial. 2 factorial is 1 times 2, so that is 2. So using this formula, then you can get this result, or we can use table, Poisson distribution table. When mu equals 3, if you can find mu here 3, then probably x equals 2, x equals 2, then 0.2240. So if you can find mu from this table, then you can use this table to find the answer, Poisson distribution. How about this? What is the probability that in any given minute more than two customers, something like this, infinite, Poisson distribution, infinite, there is no maximum number, then 0, 1, 2, 3, 4, and so on. More than 2 is probability 3, 4, 5, 6, and so on. This area, but because it's infinite, no maximum number, so this is better way. 1 minus probability x greater than 2 equals 1 minus up to 2, 0, 1, 2, probability 0 plus probability 1 plus probability 2 up to 2, subtract 1 minus 1 minus 0, 1, 2, that is this area. From the table, go back. From the table, x0, x1, x2, that will be 1 minus x0 is 0.0498 plus x equals 1, 0.1494 plus 0.224 equals 0.03233. This one from total 1 minus this much 0.12. 0.12 is 0.0498, 0.1494 plus 0.224 from table. That is 0.32833, 32.33%. Practice problem number 34. Automobiles arrive at an Elkhart exit of the Indiana Toll Road at the rate of 2 per minute. The distribution of arrivals approximately Poisson distribution. Without this one, Poisson distribution. Anyway, 2 per minute, time and counting number, so discrete, and this one is Poisson distribution problem. Because time and counting. Time, surface, area, how many, that is Poisson distribution. And then what is the probability that no automobile arrive in a particular minute? Poisson distribution, you need average, mean, mu equals it says 2. And then probability x equals 0. From the table, Poisson distribution table, here, this table with the binomial distribution table is on Blackboard under course documents. When mu equals 2, then probability of 0 is 0.1353. .53%. Without calculation, you can find answer from the table. So answer .1353. And another question. What is the probability that at least one automobile arrives? At least one. Infinite, 0, 1, 2, 3, and so on. Probability at least one means include 1 and greater than. So x greater than or equal to 1 equals p. 1 x equals 1 plus p x equals 2, probably x equals 3 up to infinite. So this is better way, 1 minus total, only this p 0 equals, we already know, we found p x equals 0. Answer is 1 minus p equals 0. P equals 0 is 0.1353. So 1 minus 0.1353 equals 0.8649, 86.47%. Actually, more discrete probability distribution, something more, but our textbook provide only 2, binomial and Poisson distribution. So that's all for chapter 6, and you will have assignment from this chapter. Assignment will be in week 4 assignment, and then up to this chapter online, and then from next week we will see in class. Whitley Hall 623, classroom Whitley Hall 623, from 5:30 to sometime Tuesday and Thursday. So online class up to chapter 6 and chapter 7 and so on in class, and see you in class next week.